All right, so the first one. A balloon is filled with 30 liters of helium gas at 100 kPa. What is the volume when the balloon rises to an altitude where the pressure decreases? Okay, so let's think about this logically. It decreases. So if a balloon that still has the same amount of helium in it, the temperature hasn't changed, even though it probably would, but say it stays constant, and it goes to a lower pressure, what do you think is going to happen to the volume? So I lowered pressure. What did our graph say? The volume should increase. So if we do this, we should get an answer with a larger volume than the first one. Okay, so logically. So let's write down what we know. P1 is like your pressure from your first situation. Okay, is 100 kPa. Then P2 is like if this gas changed. So it's the new circumstance is 25 kPa. Then V1 is 30 liters. And we are looking, V2 is our question mark, okay? V2 is our question. So our formula is P1 times V1 equals P2 times V2. If we plug this in, we rearrange and solve for V2. If you want to rearrange first, that's good too. So P1 times V1 equals P2 times V2. If I want to solve for V2, I want to get it all by itself. So I divide both sides, by P2. So what you have, you'll go 100 kPa times by 30 liters, all divided by 25 kPa. Now, if you put this into your calculator, make sure your top is in brackets, okay? Put your top in brackets there. And your volume, you should get 120 liters. And that's to sig dig, so we're all good for that as our final answer. Okay, and there's not really too many tricks with these kinds of questions. They're as straightforward generally as this. So say we have another example. The pressure on a 2.5 liter of anesthetic gas is 100 kPa. If 6.5 liters of gas is the required volume, what pressure must it be under assuming constant temperature? So if we're supposed to have more liters of gas, then our pressure must have to decrease because we're going to have to fit the same amount of molecules into a tighter space. So we think our P1 is 100 kPa, our V1 is 2.5 liters, and our V2 is 6.25 liters. And we are looking for P2 as our question. So you can rearrange to solve for P2. Divide both sides by V2. So we'll have P1, so we'll have 100 kPa multiplied by 2.5 liters, all divided by 6.25 liters, and that will give us our pressure. So the answer, you get 40 kPa, 40.02 sig. So that is Boyles Law. So now what we're going to do is we're going to leave Charles' Law,